Today we're going to look at permutations and combinations, and that is the learning target that you would be able to know which one to use and how to apply those to find the number of possibilities of doing something. So yesterday we looked, or the last lesson we looked at the counting principle and how you can find the possibilities of doing something. So we're going to kind of use that, but then we're going to look at how you can use permutations and combinations to also find the number of possibilities. This first one says when a manager of a softball team fills out her team's lineup card before the games, the order in which she fills in the names is important because it determines the order in which the players will bat. Suppose she has 7 possible players in mind for the top 4 spots in the lineup. Using the fundamental counting principle, how many ways can she assign players to the top 4 spots? Well, we want to look at, we got 4 spots here. Okay, they said 4. Okay, how many possible people for each one? Well, the leadoff spot, the first spot, she would have 7 possible players to choose from. She's got to pick one of the 7, which means there's 6 left for the next spot. Someone then is going to get picked. We'd be down to 5, then 4 spots, and so on. And for fundamental counting principle, we talked about we want to multiply all these numbers then together. And if we multiply all those together, that should give us the total possibilities. Now, be careful here. We don't want to keep going down 3, 2, 1 and use that factorial button we talked about yesterday. And the reason we don't want to use that here is because there's only 4 spots in the lineup. So we want to stop after 4 numbers have been used. So if we multiply all those together with our calculator, it gives us 840 possible lineups. Okay, so we could definitely do the problem like that, and that's the correct answer. What we're going to look at today is another way you can do that using what's called permutations and combinations. Okay, permutations are when a group of objects or people are arranged, that's an important word, arranged in a certain order. The arrangement is called a permutation. The big thing you got to know about permutations is that order is important. So if you select 2 things, A and B, that's different from selecting B before A. The order that you pick is important. All right, so here is how you find a permutation. When you're doing a permutation of n distinct objects, and they have to be different, okay, then if you take r at a time, this formula will give you the number of possibilities. N is the total. So this number is the total. And r is part of that total. How many are you taking? What's the smaller part of the total that you're taking? And how you find it out is this little formula. Notice you see that exclamation point or factorial, so you do n factorial, the total factorial, divided by n minus r factorial. And you can figure out the number of possibilities. Let's go back to that problem we just did and show you that you could use a permutation to do this. We're arranging players here in a certain order. The order is important here because we want players to bat in a certain lineup. So what we want to find out is what is the total. Here the total number of players would be 7. So n would be 7 in this problem. And the number that we're picking from that total is 4. So r would equal 4. So if we use the permutation formula, we would have 7 picking 4 of those. Okay, another way you can write that you'll see, sometimes you can also write it like this, where the total goes first, permutation, P stands for permutation, and then we're choosing 4. And to do that, what we get then is the total factorial, so here it'd be 7 factorial over 7 minus 4 factorial. Well, we got to do parentheses first. 7 minus 4 is 3 factorial, so you end up getting 7 factorial divided by 3 factorial. Let's go on our calculator and see what we get. So just like we talked about in the last lesson, factorial, go to your math menu, find the probability menu, so you have to scroll over on the top, number, all the way to the last one, probability. Find the factorial of that exclamation point, divided by, and then 3 factorial. And it looks like the answer we get is 840. Should be the same as our last one, and it is. We get the same exact answer. So that's another way you can do this problem to get the same answer. There's also another way you can do permutations on your calculator. Okay, most calculators have a built-in permutation button, and this one does as well. So to enter it on your calculator, you want to enter it similar to how it's entered right here if you have a TI-84 calculator. If you have a TI Inspire, you'll actually end up entering it like it's written right there. So I'll show you how to do that. Go to that same probability menu. So hit Math, go to Probability, and the one here listed at number 2, NPR, that is permutation. So that's the one you want to use. Now notice if you just select it, it says answer before that. You actually have to enter in the number that is n, the total, first before you select that. So I'm going to clear this. We need to enter 7 first, then select it, then enter the number you're choosing out of that, which is 4, and then hit enter, and you get the same answer, 840. So you can use that button as well if you'd rather not use the formula. Okay, so that's the total. All right, let's try some more permutation type problems here. This next one says there are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? This problem will be a permutation problem. And the reason is that order is important when we are arranging. Arranging again is important. These skaters in a first, second, and third place. That's why we use permutation. Sally winning gold, Susie winning silver, and Judy winning bronze would be a different order or arrangement than the same 3 skaters where Judy wins gold, Sally wins silver, and Susie wins bronze. So even if it's the same 3 people, the order is different, so this would be a permutation. Anytime you're arranging, it's a permutation. So let's see if we can solve this one out. What is our total here? 10, so that's our n, and we're arranging them in gold, silver, bronze. That's 3 particular spaces, so here r is going to be 3. Okay, so if we put that into our formula, we get 10 factorial over 10 minus 3 factorial, which is the same as 10 factorial over 7 factorial. So you can enter it like this to get your answer. Do 10 factorial divided by 7 factorial, and you can get it. Show that here. So you can enter it in just like we have it written, and you get the answer that way. Answer is 720. Or you can use that permutation button too. Remember, if you're doing the permutation button, okay, hit first the total, which is 10. Select permutation out of your menu, and then select the number you're doing, first, second, third, or gold, silver, and bronze here, so 3 places, and you also get 720. So either way is fine. Whichever way you think is the easiest for you, do that way. So 720 possible gold, silver, bronze medals could be awarded here. All right, the next one here, why don't you pause the video, try it out, see if you can figure out the number of possibilities in this one. Okay, let's see what you got. The newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to cover it? This is a permutation because each arrangement's different, each story's different. You would have a permutation of 9 selecting 4. So if you do this on your calculator, you should come up with 3,024 ways would be the answer. All right, let's take a look at another problem. Number 3 says, how many different ways can the letters in the word geometry be arranged? Okay, this is an arrangement. If you see arranged, good chance you're doing a permutation, and it is. Okay, we want to know how many ways can we arrange the letters here. We're going to have to find out how many letters. We got 1, 2, 3, 4, 5, 6, 7, 8 letters. Okay, so our total is 8. How many of them are we arranging? Well, all of them. we need to arrange all 8 letters. So this would be a permutation of 8, selecting 8. Okay, if we put that in our formula, that would be 8 factorial over 8 minus 8 factorial, which would equal 8 factorial over 0 factorial. Now, some of you might be thinking, uh-oh, we can't do this one. Well, actually, you can. 0 factorial doesn't actually equal 0. If you do 0 factorial on your calculator, it actually is 1. 0 factorial is the same as 1. So this is really 8 factorial divided by 1, which is just going to be the same as 8 factorial. So anytime you're arranging and you're arranging all of the things, so if you do permutation of 8 select 8, that's 8 factorial. It's always going to be just the same as the factorial button. So we could figure that out. The problem here is if we do this, 8 factorial won't give us the correct answer. And that's because if we were to, let's say, rearrange this by switching these 2 letters around, it still says geometry. That's not a new arrangement. We have a repeat here. When you get a repeat, your permutation or the number of ways of doing things changes a little bit. So if you have repetitions, what we say is the number of permutations of n objects, n still being the total, which p are like and q are like, is given by this equation here. So the top is still our total, okay? Q and P would be things that are repeats. So if you get repeats, you divide by that, how many there are, factorial. So on this particular problem, if we want to find this out, what we're going to need to do here is the 8 factorial we talked about, because we're arranging 8 things, but we have this repeat of these e's. Okay, and there's 2 of them, so then we divide by 2 factorial. So on our calculator, to find the number of ways of doing this that are different, we need to do 8 factorial divided by 2 factorial. So if we divide this out, looks like the number of ways of doing this is 20,160. That's the number of different ways of arranging it, where if we just would switch, say, the 2 e's, that's not being counted. Let's try another one of those with repeats. Okay, this next one says, how many ways can the letters of Mississippi be arranged? Okay, so again, if we're arranging all these letters, we need to know how many. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the number of ways of arranging 11 things would be 11 factorial. But you can clearly see there is repeats here. For example, we got 1, 2, 3, 4 i's. So what we're going to need to do then in this problem is divide by, since we have 4 of them, 4 factorial. We also have 1, 2, 3, 4 s's. So we got to divide by another 4 factorial. And we're still not done here. We have some p's. We got 2 p's, so we got to divide by 2 factorial since there's 2 of those. So to get this problem, we're going to have to divide 11 factorial by 4 factorial, 4 factorial, and 2 factorial. All right, so go on your calculator. Okay, if you type that in, you should be able to get the answer. Okay, and once you got it typed in here, you can hit equals and you should be able to get the answer. Now, if you go through and do it just as I just did here and get this answer and say this was a quiz question, you would get it wrong. Now, it looks like it should be the right answer. What I have entered right here looks pretty much exactly like I got there. However, your calculator does not calculate it the way you want it to. What your calculator sees is order of operations. Okay, remember, order of operations, you work left to right. So what your calculator will do here is divide these 2, but that's it. Then it's going to see multiplication and multiplication here. We don't want it to divide just one of them and then multiply by the other 2. We want it divided by all of those. So on a problem like this, in order for you to get it correct, what you're going to need to do is use a parentheses. So we still want to do the 11 factorial like we had. Okay, but then what you're going to need to do next after you have your 11 factorial is hit divided by parentheses and now enter the other ones. 4 factorial, another 4 factorial, 2 factorial, and then close the parentheses up. Now your calculator will do all the multiplication in parentheses and then divide the two things. So the actual answer here, the one we want to get, is 34,650. So that would be the number of possibilities. All right. Next, the other one we're going to be looking at is combinations. Combinations is an arrangement or selections of objects in which order is not important. That's called a combination. So sometimes you want to select things, but you don't really care about the order as long as you're selecting different things. Okay, so the big key with combination is order is not important. Selecting A and B is the same as selecting B and A. We don't care if A is selected before B or B is selected before A. We don't really care. We just want to select those two things. The formula for combination looks very similar to what we had for the permutations. We still have a total, that's N. We're still selecting part of the total, that's R. And on top of this fraction, n factorial, that's the same as we had before. The n minus r factorial is the same. Here's kind of the new part. Because we don't care the order, we got to divide by another r factorial. So that's the difference in the formula. Combinations have the same thing though. You have a button on your calculator that we can also use to do these, and we'll show you how to do that. So let's look at an example of a combination. Number 4 says a group of 7 students are working on a project and it needs to choose 2 students to present the group's report. How many ways can they choose the 2 students? This particular problem here, the order is not important. Say the people in the group are Sam, Ella, Marissa, Katie, Tyson, Scott, and Kevin. If Sam and Ella are picked to present, that would be the same as picking Ella and Sam. We don't really care who's first. We just care what 2 people are getting picked. So order does not matter in this case. Okay, we have a total of 7 people choosing 2. We don't care the order. We call this a combination. So it would be a combination of 7 choosing 2. Okay. You might also see it sometimes written like this. And that's how we need to enter it here if we're going to use the calculator function. So we'll show you how to do that on the calculator here. You can use the formula. It'll work. It'll be fine. Let's do it with the calculator button. That's a little bit easier. So enter 7 first, then hit math. Go to your probability menu. Number 3 here, you can see NCR, that is combination. And then enter 2, enter. And that tells us that there is 21 different ways that this group could select 2 people to present. Let's try another one. Number 5, 5 cousins at a family reunion decide that 3 of them will go to pick up pizza. How many ways can they choose the 3 people who will go? Does the order matter here? Nope, it doesn't. Okay, we're just picking 3 people to go. Now, if it said who's driving, who's sitting in the passenger seat, and who's sitting in the back seat to go, well, then you're picking a certain order. Then you'd use permutation. But here, if it's just picking 3 out of 5, that would be combination. So we do combination of 5 choosing 3. If you put that in your calculator and solve it out, we should get, let's see, pick combination, enter 3 people. Looks like there would be 10 different ways we could choose a group of 3 out of 5. That's combinations. All right, we're going to try another combination problem here in a second, but these next two involve decks of cards. So we're going to talk about what a deck of cards looks like. Some of you may be familiar with it, others of you may not be as familiar, so we'll make sure everyone's on the same page. A standard deck of cards has what's called 4 suits. Okay, these we call suits. And they are clubs, spades, hearts, and diamonds. And they're indicated on the cards here. There's a little symbol for each one. And in each of these 4 suits, there are a total of 13 cards in each suit. This first one here is called an ace, and it kind of acts as a 1. And then there's 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see up to here. And then these last 3 cards over here also are part of each suit. So if we have 10 plus another 3, there's 13 in each suit. Okay, so if we have 13 suits, or sorry, 13 cards and 4 suits, 13 times 4 is 52 total cards in a standard deck of cards. These last 3 cards in each we talked about are called a jack, a queen, and a king, and they are referred to as face cards. So these 12 cards over here are what's called face cards. So if you ever hear some referring to face cards, those are it. Also notice half the cards are red and half the cards are black in a deck of cards. Okay, so let's try to answer a few questions here. Number 6 says 5 cards are chosen from a standard deck of cards. How many hands consist of 3 clubs and 2 diamonds? Now in this problem, did they ever talk about the order in which you're getting these cards? No, we don't care what order we get the clubs and diamonds, just that we get 3 clubs and 2 diamonds. So if order is not important, this is going to be a combination problem. Okay, so we need to figure out now how many ways of getting 3 clubs and 2 diamonds. Well, these are 2 different things. Clubs and diamonds are different sets of things. So we're going to have to do 2 combinations here to figure this out. We're going to need a combination for both. Okay, let's start with clubs. There's 3 clubs that we need to get. What we need to do though is figure out how many total clubs are we picking from. So if we go back to what we just looked at, clubs are, there's right here, these are all clubs. We know there are 13 of them. So we would have 13 clubs selecting 3 of them, where order doesn't matter. Diamonds, there are also 13, but here we're getting 2 diamonds. Okay, so we have these 2 combinations. And we could go through and figure these out. If you go on your calculator and do this one, this is going to turn out to be 286 ways. And if you go on your calculator and do this one, this is going to turn out to be 78 ways of getting the 2 diamonds. Well, what do we do with those 2 numbers? Well, remember back to the counting principle we looked at in the previous lesson. When you are doing multiple things with possibilities, we multiply them together. So here what we want to do is we want to multiply these 2 numbers together. Okay, so go on your calculator, do 286 times 78, and you should get that there would equal 22,308 ways of doing this. So when you have different sets of things, you need to use multiple combinations or permutations and then multiply them together to get the total. All right, let's try another card problem. This one says 6 cards are drawn from a standard deck of cards. So we know standard deck, we just talked about it. How many hands consist of 2 hearts and 4 spades? Very similar to the last problem. Once you pause the video and try this one out, see if you can figure it out. All right, let's see what you got. Again, order is not important. They didn't talk about which order we're getting the cards, just that we get 2 hearts and 4 spades. Okay, the number of ways of getting the 2 hearts, there's 13 of them. We're choosing 2 times, because we need another one here. This is another combination of 13 spades, choosing 4. If you figure these ones out, this first one ends up equaling 78. The second one ends up equaling 715. If you multiply the 2 together, The number of ways is 55,770 possible hands that have 2 hearts and 4 spades. All right, one last one here. Let's check this problem out. So this last one says, 6 cards are drawn from a standard deck of cards. How many hands consist of 2 cards from one suit and 4 cards from another suit? Now, if you look at this problem, very similar to the last one, 2 cards, 4 cards from 2 different suits. We just had that on the last problem, 2 and 4. So would the answer then be the same? Would it be 55,770? Well, this problem is a little different in that we don't know what suit we're picking from. In the last one, we knew the suit. They told us it was hearts and spades. Here we don't know the suits. Okay, so that adds in some more possibilities here because we could have different possibilities of the suits that we're choosing from. So we still would want to do the same 2 combinations in this one. 13 cards of some suit, picking 2, and 13 cards of some other suit, choosing 4. But what's different is we need to know how many ways we can get the 2 suits. Now, is the order of the suits important? Yes, because the first suit, whatever suit we pick, say the first suit ends up being clubs, can that be the suit as the next choice? No. The order is important when choosing the suits. So what we're going to need to add to this is a permutation. Because the order of the suits is important, whereas the cards are not. So how many suits do we have? There's 1, 2, 3, 4 suits. And the number of suits that we're getting is 1 from one and 4 from the other. So we're choosing 2 of the 4 suits. So we got to figure out how many ways of doing 4, choosing 2 where order is important. So we already know these 2, and we figure that out, will give us this number. What's this going to give us? So let's do this permutation here. We're doing 4 things. We're picking 2 of the 4. How many ways of doing that? There's 12. So we're going to get 12 here. Now we got to multiply these 2 numbers together to get the total. So 12 times 55770. The total ways of getting 2 cards from one suit and 4 from the other would be 669,240 different ways. Okay, so that's permutations and combinations. Why don't you try some of these out now on your practice sheet?